Welcome to a transient analysis of Veritasium, Energy Doesn't Flow in Wires circuit using quicks. My name is Gary Miller. The simple circuit in the video lends itself to transient analysis using readily available software tools. The size of the circuit dictates that distributed parameter analysis is the most appropriate choice, as opposed to lump circuit analysis, as many of the commenters have used. Distributed parameter analysis models the long lines as transmission lines. The lines have a characteristic impedance given by the square root of L over C, where L and C are the inductance and capacitance per unit length. The characteristic impedance of the line gives the ratio of the voltage to current for traveling waves down the line. I chose the freeware tool Quicks, QUCS, to perform the transient analysis. The model appears in this slide. The voltage source of 15 volts is divided into positive and negative 7.5 volt sources with a reference node sandwiched between the two voltage sources. A small resistance is used to represent the internal resistance of the voltage source. An ideal switch is used that switches at 1 nanosecond. Long transmission lines are connected to either side of the voltage source resistor switch string. They're terminated in a short circuit. The load resistor is connected to the transmission lines as shown. The voltage across the load is given by the expression V1 minus V2. The transmission line lengths were chosen to be such that the transient analysis would not take too long, but would also demonstrate the delay associated with the given length of line. In this case, the cables are 3 meters long. The transient analysis was performed from 0 to 2 microseconds with a time step of half a nanosecond. The results of the transient analysis are shown in this slide. I chose some arbitrary values for characteristic impedances, line lengths, and resistance values, and these can be changed easily. Physically, once the switch is closed, voltage waves are launched down the transmission lines. Due to the connection of the load to the transmission line, some small but finite voltage appears across the load almost immediately. At each end of the transmission line, reflections occur and voltage waves bounce back and forth. From the graph, one sees V1 is greater than 0 and V2 is less than 0. Their magnitudes are the same as expected from symmetry. Careful observation of the voltage sources shortly after the switch is closed shows the buildup of the voltages in steps, and the step duration is given by the round-trip time delay through the transmission lines. As time marches on, the steps become smaller in magnitude. The buildup of the voltage across the load increases slowly, increasing the transmission line lengths and/or making the impedance mismatches larger, increases the time delays. I hope this sheds some light from a transient circuit analysis standpoint as to the physics behind the system response in the Veritasium video. Thanks for listening.